My name is Chintana, so I'll be first taking and then talking about little bit about the problem and why. So set the stage for the demo, why we need an internal developer platform, and then we'll do the demo, and then we'll also talk about the next sessions that's going to come up in this track. So first of all, if you look at kind of how we interact with our favorite brands today, so we not just call them and then just call them and then go to a store anymore. So every one of us need to be able to interact with our phones, search the products, look at the catalog, look at the descriptions, and then make purchases using our mobile phones. And if we on the y-axis, you have how the customer capabilities. So these customer capabilities has also evolved. So not just collecting contact information and contacts and information, but customers are kind of demanding better digital experiences from these applications. So in order to deliver on that promise, the core business systems that's been used by organizations have to fundamentally evolve to make that happen. So on the x-axis, we see, first of all, we started with email, and then now on, these days what we see is all the businesses need complex integrations, custom APIs, custom apps, and then now we are in the era of how to integrate intelligent AI agents into the customer experience. So the fundamental truth is that every business is now becoming like a software business. And then we'll look at two developer stories. So first of all, we'll call them developer A and developer B. So on the left-hand side, developer A go and joins a startup organization, right? And what they do is in their first day, they check out the code, make a small change, and then push that code to production. So they feel incredibly kind of empowered, they are excited, and then they like to work and then keep on working on this code base. On the right hand side, another developer joins a large established organization, and on the first day, or maybe in the first week, or even in the first month, they are struggling to get the application running on their laptop. And they are kind of stuck in this maze of support tickets, outdated documentation, wikis, and so on. So it's a daily struggle. So the key differentiator here is that not the skill of the developer, but the path that they've been forced to walk to get these applications into production. So it's a problem with the architecture and the processes that's been created on behalf of them. So we come to this architectural kind of crossroads. On the right hand side, you see a greenfield innovation, and then on the left hand side, you have this brownfield reality. So this is kind of the reality that every company, every organization find themselves at. So on the greenfield side, it's all about building kind of new and modern cloud native applications, and then it's all about speed and innovation, and then that's kind of the future that you are building for your customers and maybe also for your organizations. On the left hand side, you have the brownfield reality. This is where your core business systems exists, and these are the business systems and other services APIs that power and run your organization today. So this has to be kind of managed, and then this has to be modernized, and then you have to pay down years of technical debt for these systems, and this is kind of the reality or the present that you face in. So every company faces this dual reality, but you cannot choose one of these. So you have to master both of these simultaneously to be able to compete in the markets that we have today. So for the agenda for this session is that, so by the end of this session, we wanted to give like a strategic blueprint to navigate this dual reality effectively. So we'll start by defining what this greenfield, brownfield landscape is about, and then we'll talk about how we can pave a path forward by using modernization strategies. And then we'll talk about this unifying solution, the platform that will bring everything together. And then we'll do a demo of how to deploy an existing application using an internal developer platform. And of course, we'll conclude by setting the stage for the next couple of sessions. So let's start by defining the landscape. So greenfield, it's basically like giving developers a new plot of land. So you have the complete freedom of choosing how you build, what you should build, and so on. So you can decide what are the best tools, what are the best materials, and then what are the cool new designs, and then you can start building on this clean plot of land. And then in the software world, when it comes to software analogy, it's basically there's no legacy code involved. So you can, or legacy code or any policies or constraints. All your development teams have the complete freedom of choosing the tech stack they want, and then it's about you can get started and go to production very, very quickly. But the hidden challenge here is that if you give 10 different teams 10 different like plots of land, they're going to build, you're going to end up with 10 different, vastly different designs. Or in the software world, it means is that each and every development team are going to choose their own technical stack, their own ways of doing things. And then this is going to be a problem because now you have to deal with this architectural sprawl and then consistent designs that you have to deal with down the road, and it's going to create a management kind of nightmare. On the brownfield world, it's not like building a new thing. It's more like trying to renovate like a 100-year-old building. So you have to work around the structures that's in place, the old wiring, plumbing, gas lines, and whatnot. You can't just knock down walls as you see fit. So the change is very, very slow, very complex, and very risky. And this, of course, a picture from this farmhouse where the family inherited this 100-year-old house, and then how they renovated that house over like 5-year time frame. So in the software world, if you look at this old wiring, so we have the monolithic architecture, right? So monolithic architecture is you have systems with very, very tight coupling, and then all the components are bound together. So in order to make a small change, you have to basically understand a lot of complexities, and then it requires deploying the entire application even for a very insignificant change. And of course, then there's technical debt. So with years of quick fixes that's been applied and outdated libraries, and then there's no way of verifying the fixes that you made, so there's no testing involved. And then that has made these code bases extremely fragile and then very, very hard to work with. And then, of course, there's this high cognitive load. So cognitive load is about what kind of the things that a developer should understand before making a change to a complex system. And then there are, of course, inconsistent environments. So we have this problem of like age-old problem of it works on my machine, and then it's going to come up in, it's like a daily firefight that you have to deal with. Every single change, every single integration that you have to do is going to work on your machine, and then when you deploy, everything is going to break. So a lot of these monolithic brownfield systems kind of exist in like a virtual machines in multiple virtual environments, usually VMware or any other virtualized environments. So these can be modernized a lot of people, what they do is, they do kind of a lift and shift and take a virtual machine and then move that to a cloud provider. The problem of doing that is now you just completely took a mess that you have and then moved to a very, very expensive location. And then on top of that, you don't gain any kind of the cloud benefits that you ideally would like to have or like to get, like scalability, being able to build resilient systems, and then the cost efficiency that cloud providers bring in. So this simply having been to change the location to a new place doesn't fix the underlying core problems and core issues. So it doesn't fix the architecture, so a lot of problems are associated with that. So now we know kind of the landscape that we have to deal with. So what are some of the ways that we can use to modernize these applications? So modernization is not like an all or nothing game, right? So it's a spectrum of options that you have or you can use for different monetization strategies for different applications. So you have rehosting, replatform, and then repurchase, etc. So for the strategies that we discussed today, we'll focus on the strategies that lead to true modernization. So let's first look at what are these quick fixes, right? So first, rehosting. Rehosting is, as we discussed, you move a given virtual machine to a cloud provider. It's very, very fast and low effort to do that. But it's going to be expensive, and then it doesn't fix the kind of the underlying core problems or core issues that's associated with that application. So the next option is doing just replatform. So replatforming is a bit of a step up from rehosting. So replatforming is you might have a managed database or on-prem database that you have, and then you might move that to a managed service from a cloud provider like RDS. So it provides some benefits, but still at the end of the day, you are dealing with a monolithic system. So these tend to be kind of stop gaps. They are not really recommended for a good enough long-term solution. So strategy 2, this is where the true modernization comes in. So you either refactor or re-architect an underlying application. So re-architecting an application is about completely or fundamentally changing the internal structure of an application to be more modular, to be able to deploy more resiliently, and then being able to deploy certain parts of an application in a more scalable manner. So this is an extremely difficult path to do, but this is the path that yields the highest value long term, right? So a lot of the time people have, when you get to this point, one of the major questions a lot of the organizations have is that how do I do this effectively without stopping new feature development and then allocating resources and then halting everything and doing like a 2-year rewrite of my application, right? So answer to that question is kind of a technical proven pattern called the strangler fig pattern or the strangler pattern. So this is an analogy from kind of nature. So strangler fig is a kind of a vine that grows on trees. So it starts very, very small, and then over time it goes stronger and stronger, and then it grows to a point where it consumes the entire tree. So same fundamental principles in software as well. So incrementally and safely kind of replace certain parts of the application with more modern services. And then how a strangler pattern works in practice. So basically you identify a module, right? And then it can be billing or order processing and etc. So identify a single piece in the monolithic application, and then you build a completely new service, microservice, to implement or handle that subsystem. In this case, it can be like new set of microservices to handle the billing function. And the third step, this is kind of the important step, where you intercept traffic that comes to the monolith, and then install or deploy either an API gateway or a proxy in front of the monolith, and then all requests comes to / say billing. You reroute that all that traffic into the new microservice, but still the other traffic goes to the existing monolith. And then you kind of repeat this process. You carve out another piece, you carve out another piece, and another piece, and then keep on replacing, keep on building new services, and keep on replacing the monolith functionality until all the responsibilities of the monolith are no longer kind of valid and it can be safely retired. So it's a very, very low risk process, and then it also delivers incremental value as you go along. The major advantage here is that you can avoid completely like big bang rewrites with this approach. So now we know this strangler pattern is a kind of a good pattern that we can use to modernize services. But if we now take a step back and then zoom out and then look at the kind of the bigger picture of this software manufacturing landscape today, you have fundamentally developers building kind of business value, and the idea is that you need to give this or take this value into the hands of the customers as soon as possible or as fast as possible. So you have on the left hand side, so developers on the software creation part is also not without any challenges. So at the creation time also developers face a lot of friction. So being able to reuse code or being able to reuse existing services, existing APIs is a challenge. And also allocating resources to deploy these applications also takes a lot of time. And then collaborating with other developers, other teams, and doing a complex application is also not that straightforward to do. And then of course, on the right hand side, idea is that we need to push this code into consumers, right? So the major source of pain in this process is the gap or the middle you have where the developers are writing code and then they want to push that code to production. So this is where you have things like your runtime architecture, CI/CD process, DevOps, different environments, security operations, config management, version management, testing, observability, analytics, SRE, and kind of the list goes on, right? So incredible amount of complexity on the middle part for this. So all of this complexity is there so that a developer can or a business can add value to their consumers or add value to their digital experiences. And this is kind of the cognitive load that we'll be talking about next. Kind of the complexity that a developer has to deal with to be able to push things to production. And there is a solution to this, of course. So the ideal, the theme of the track here today is an internal developer platform is designed to solve this cognitive load of developers that we face today. So this is kind of the reality of modern developers, right? So this is a picture from CNCF. CNCF stands for Cloud Native Company Foundation, kind of an organization that handles a lot of the cloud native projects and technologies like Kubernetes and so on. So now developers has to kind of understand like Kubernetes, Docker, maybe AWS, Argo CD, Prometheus, Grafana, Istio, etc., right? So all of that complexity just to be able to deploy a simple app, right? So all the developers in your organization, do you think it's kind of scalable or practical to understand this complexity to be able to deploy a very simple application? I think the answer is no, right? So it's an unsustainable goal, so it can't be done practically. So there may be one or two developers who understand really well, but when the organization gets large, when the application complexity gets a lot more wider, and then there are a lot of integrations involved, you need to be able to hire a large team to tackle this complexity, right? So that's where, and then of course, in the hiring process, I think in any organization, it's impossible to hire like the 10x developers, right? So that we've heard from other like the rockstar developers, right? So you have a spectrum of developers with different skill levels. So you need to be able to make these developers as productive as possible in order to deliver business value. So we need a unifying solution for this, right? And then, so what if we stop giving all our developers a big box of tools and instead give them like a kind of a paved path so they can walk to deploy the application. So from all the way from building, deploying, testing, managing, running, and observing kind of any kind of application. So if we can give them a paved path, it reduces a lot of this friction, right? And that is a core idea of an internal developer platform, this paved path or a golden path for developers to go from their code to production in minutes, basically, not months. So what is an internal developer platform? So the formal definition of an internal developer platform is internal developer platform, or IDP, is a product so built by a platform team and whose customers are the company's own developers, right? So some of the questions that we get here is that a lot of people are asking, who are these platform team? Is this platform team coming from a different vendor, or who are these? So this is basically your own operational or DevOps engineers who will be managing this platform for your developers, right? And then the goal is to radically simplify the developer experience and kind of abstract out all the infrastructure complexities from the developer workflow, right? So developers, and then give self-service functionality, self-service capability for developers, not having to wait for another infra team or wait to get another like operations team reply to a ticket and provision a database. And of course, enforce standard best practices by default, right? So the platform should enforce its best practices by default, so that developers don't have to like read external documentation, external wikis, coding standards, etc., when they start developing products. So there are several core IDP capabilities and features like self-service, golden paths, abstraction layers, etc. So I'm going to skip this slide, and we'll talk a lot more about these features in detail when we are going through the demo. So we'll talk about these capabilities in the context of the demo. So you have an interactive session to understand these features. And internal developer platform, so this is where it all comes together, right? So the dual reality is managed by a single unified platform. So for brownfield modernization, an IDP or an internal developer platform provides a golden path for new microservices that's created from this Strangler pattern, right? And then it also ensures each and every piece that's developed is done using standards and then deployed consistently and securely. And for all the greenfield innovation, right? So IDP provides like a central launch pad where a developer can follow like a golden path to get an idea from ideation stage to a running production app in literally minutes. And then the same governance, same security policies and consistent environments are applied to all the greenfield development and teams as well. So we'll now switch to a demo, and then we'll come back later and then discuss.
So what we want to do now is to basically get an existing application and run it on Choreo. So if anyone wants to follow the demo, we have the entire tutorial, everything in GitHub. If you scan the QR code, you'll get it. So let's get started. So the project is a simple web application. It has a backend written in Go, and it has a front end written in React.js, and then you have a database. And let's get started. So the choreo is located at wso2.com/choreo. We go here, this is where it's going to be. You can log in using your GitHub, Gmail, Microsoft accounts, etc. Once you log in, what you see is here. We generally call this particular UI the visible, right? Okay. Generally call it the control plane. My code is in this particular location. It's in wso2.com/choreo. So this is the architecture, how it looks like. You have React Web front end and a back end, then MySQL. And the code is here. It has two pieces. First one is the back end part, the front end part. So we'll start by basically deploying the back end part of it. We'll create what we call a project. Project is a logical grouping of things that you can create on Choreo. Let me create something. We'll call it banking demo, and click on create. Once you do that, it will show you the things that you can deploy on Choreo. We call these components. It could be a service, it could be a REST service, it could be a gRPC, GraphQL, that kind of workload, or it could be a web application, or it could be something that you want to run once in a while. Think about scheduled, basically running a data migration, or maybe some sort of a script and etc. Or it could be something else, things like MCP servers if you are into AI programming, if you want to do PO API management, API proxies, and a bunch of other stuff. And for the purpose of this particular demo, I'm going to create a service. Click on service. Click on continue and show where the code is. It's in my GitHub repo, Ramith, and the code is in this particular repository. And the place of the code is, we see that it's in the backend. With that, click on continue. I'm going to give it a unique name. And given that this particular piece of code is written in Go, I'm going to select what we call the build preset as the Go. The idea here is that you can build and deploy this application without even writing a Docker file. That's the whole idea here. So which is basically some advantage for developers. So with that, depending on what we clicked here, we will ask a bunch of questions and then let you create the workload. Click on create and deploy. Now, while that happens, now this particular application needs a database. So okay, something happened. So now, matter of seconds, it just created a whole lot of things behind the scene. It creates the CI/CD, the environments, a lot of things, and eventually show you with a nice dashboard for this particular workload. Now, to get to this level of maturity or the automation, it takes a lot of effort, or you need to send a lot of emails and talk to different teams and etc. to get things started. When you, especially if you are running, kind of trying to deploy a new workload onto your systems. So, but with Choreo, you can do this in a matter of seconds. That's the whole idea. So now this particular piece of application requires a database. So I'm going to go and create a database for this while this happens. So that I can do at the organization level. Go to resources. This will show you the bunch of things you can create: databases, vector databases, message brokers, and something else also. Click on databases, click on create, and it will show you the things that you can create there as well. I'm going to select MySQL. Let's give it a name. I'm going to call it banking DB example. Click on next, and it will let you select where you wanna create this particular database. So I'm going to pick DigitalOcean as per the tutorial says, and select a service plan. This is basically the hardware spec, and with that, click on create. Now this particular piece will take a little bit of time to provision the database. Therefore, I'm going to switch to something that I already have created just to save some time. So this is being created, but if you look at the one that is already created, you can see there are you have the host name, ports, and usual stuff, as well as you can go and create databases here. Then you can have a situation where you will list these databases in a common UI. We call it the marketplace, so that people can find it and reuse and etc. We'll go there as well. Then you can make sure that these particular databases can be seen in different environments also. We'll get to that as well when time goes in the next steps. So let's go and see whether the backend is created. And when you create a backend, it will go and basically build it as well. At this point, you can see it was built. And if you look at the details, you will see the build logs coming in, security scans are done, that sort of things happen by default. But of course, you can modify these things as well. So waiting for that to come, you can see the source code was validated, then the build. If you look at the build log, it's all here. And eventually, it will get pushed to a container registry after building it. So this is what building process looks like by default. Then comes the fact that we want to deploy this somewhere. So when you log into Choreo for the first time, you can see you are given with two environments, the development environment, the production, and you can have a situation where you create these environments in your infrastructure as well. In the next one of the sessions, we will cover that part as well. But when you log in, you will see two environments by default. So now Choreo takes one step, that is basically building it. Automatically it will go and try to deploy, but then again it resulted in an error. The reason being, this requires a database. So now, therefore, what we need to do now is to configure the database so that the backend can access that. So the way it happens is via this abstract concept of a connection. So the connection from one particular workload to another, it could be this scenario, it could be a database, or it could be a service also. That is basically one microservice going and talking to another microservice. But then again, this particular scenario, it's going to be a database. The beauty of this is that you can just have it listed here. When you click on selecting the databases, you can see there are the two databases that I already have for this particular workload. And of course, you can control who can see what, who can access what, and etc. So select the database from here. This is called the marketplace, and give it a name for this particular connection. I'm going to call it banking DB. And the way I have configured the database is that I can see the same database in the two environments. It could be for the development environment and the production. But of course, in the real world scenario, these are two different databases made available for two different environments. So then you select what is the credentials to be used and etc. With that, I'm going to click on create. So when I do that, the Choreo will show me bunch of instructions. This is basically to program your workload to access these database credentials in a particular way. That is by using environment variable. Given that we know that this particular workload is written using Go, we will show you the code pieces to access this in Golang. But suppose if you wrote this in Go, maybe some other language, let's say Node.js, maybe Java, we will show what is required accordingly by basically looking at your workload. Then there are a bunch of other configurations that I need to do. This is already been done in my particular workload. So if I go here, you can see I made that already available in this particular place. So therefore, I don't need to make the change right now. But usually, when developer adopts Choreo, they have to go and do this. So now the connection is done. So the next thing would be to deploy this particular application. So let's go there. Click on deploy. And at this point, I can click on configure and deploy. And we will deploy this to the lowest environment there is, that is the development environment. There's a wizard coming in. I'm going to click on next, and eventually it will show me a bunch of other details around how to secure this particular workload using OAuth and etc. and fine-grained access control. And with that, I'm going to keep everything as it is and click on deploy. Now I'm clicking a lot of buttons here and there. This is for the first time. After all this piece is done, it's all about committing your code, and Choreo will take the do the rest that is required to deploy this onto your environment. That's all. So now you can see it is deployed on the lowest level environment. And what's the next thing that we need to do? We need to test this. For that, I'm going to go to the test menu, click on the console, and it will give me a nice UI to basically test this. So you might be wondering how we draw this particular piece of UI. That is basically by looking at your OpenAPI specification for this workload. So based on that, we draw this particular UI. And what to note here is that developer is not really worried about how to secure this, where's the gateway is, where it was deployed, and none of it. He just deployed it to an environment. Now he's ready to test it, or maybe your QA team is ready to test it. So what to do here would be expand this, and we'll send a sample request and see, try it out. Let's put a username as 1. Click on execute. There you go. You can see the curl commands generated. You can see the response coming in. I already have some data in this. That's why I get it. So what this means is I just deployed an application with a database, and it's running in development environment. I can test it out also. That's what it means. Matter of minutes. So suppose we did this, we did a proper testing round in the development environment. If that is the case, the next step would be to promote to the next environment. In my case, it's the production. But then again, of course, you can have many number of environments as you need. It could be development, testing, UAT, then comes production, and etc. All these can be configured. It could be either hardware that or infrastructure that we provide, or it could be high infrastructure that runs on your cloud account, or either on-prem Kubernetes. That's fine too. So click on promote. When that happens, you need to provide basically the new configurations if there are any using the wizard. And again, familiar UIs, we promote it to the production. So let's do a quick round of testing in the production also, just a kind of sanity test. Go to console in the testing, select the environment, let's see, let me quickly go there. Okay. Okay. So let's send a request and see whether it works. You can see the workload is running in production also. It works. So now the beauty of all these things is that when you do all these things, it will automatically list your workloads in what we call the marketplace. The marketplace is where it's the service catalog. It's where all the available configurations are listed. There, it's where all the databases listed and etc. So your development teams, different teams come to marketplace to find out what's available for them, what's there to reuse and etc. That's the whole idea about the marketplace for internal teams. You can see there are a bunch of services that I created exist here. And my databases are also here. You can see there are 2 databases. If you have any common configuration files and etc., configurations and etc., you can have them listed here as well. So the idea here is basically you can control who can see what, who can get to use what and etc. in a governed manner. That's the whole idea about the marketplace. So if you click on one of these, let's say, workloads, you will see the API definition. It will give you instructions around how to use it and etc. If you provided additional documentation for your workload and etc., again, it will be displayed here for other people to see. And the same goes for any other enterprise assets. Now coming back to the demo, I mean the things that we are deploying. So we have deployed the backend part of it. It works. It connects to a database and etc. The next part would be to deploy this, deploy the front end of it. So again, I'm going back to the project level. Next step would be to click on create and bring in the web application. But before we do that, let me quickly show you something. You can see there's a small widget here called architecture. So if I click on that, you can see now it shows you how the traffic is coming in, and you have your workload, and it goes and connects to a database in real time. As you wire things up, this is how it looks like in terms of the architecture. So let's revisit this one after we create the front end also. So going back to the project level, click on create. This time I'm going to click on the web application. Again, the code is in my GitHub repository. Branch is the main, and we are going to deploy the front end. I'm going to put a prefix just to make it unique. And the build preset for this would be React. Click on that, and we'll ask a bunch of questions around the build command and the versions and etc. Let's provide these things. npm run build, and this is going to be on the dist. That's the location. What version we are going to use is 20. With that, click on create and deploy. Okay, so we can see the build is queued. Eventually it will start. Any questions up to now? Okay, let's wait for it to happen. Or maybe we can go to, until this one builds, we can go to the next step, that is to connect the front end to the back end. That also happens via our abstract concept of the concept of a connection. Therefore, I'm going to go and click on the connection. And this time, it's only meaningful to connect a front end to a service, not a database, right? So click on the service, and we can select what service this needs to connect to. So in my case, it's going to be the live backend. Click on that. Let's give it a name. Connection to BE. And the access mode is basically help you to figure out or maybe set the scope or the kind of restriction, whether this particular traffic path is within the organization or the infrastructure or the environment, or it's basically coming out of the public internet. Now, obviously, this front end is running on a browser, therefore the traffic is coming out of the open internet. So we can select public, and the authentication scheme is OAuth2. Click on create. Now, if you are a full stack developer, you know the hassle of connecting from a front end to a back end. It's a headache. Usually involves sort of OAuth related dances and token refreshers, expiry, different frameworks and stuff like that. Everything is involved, but then again, what we did here is basically improve that particular developer experience. Now, none of it applies. Basically, we will do the OAuth dance for you. We will keep track of the tokens and everything, and give you a simple enough configuration to control all these things. So if you are a full stack developer, this particular guide would make sense. It tells you to program your particular API access from the front end to the back end in a particular way using a relative path for the APIs and etc. And basically what this means is add this particular configuration to your front end and use it in a particular way. We have standard documentation around this and etc. And I wrote the program in that particular way, so I just need to configure it, and this particular piece of information is required for that. So I'm going to copy it, and when suppose the build is done, yeah. So the build is done. Next step therefore is to go to deploy and click on the configure and deploy. And then it will ask for configurations that you need to provide. And when it started running, the configurations is going to be at the public/config.js. This is the place this particular configuration is going to be mounted, and this is the API URL that I need to provide to access this particular API that we have in the backend. With that, we complete the wizard. Let's wait for that to happen. Okay, that became active. So you can see there's a web app URL appearing here. Let's click on that. And you will see the React front end on the browser. Now you see the login screen as well. This is basically part of our authentication management scheme. We call it the courier managed authentication. Basically, it manages the token the way I explained before, and we come with a built-in identity provider as well. For the lower level environments, it's pretty useful. I'm going to take a username and a password from that particular identity provider and use it to log in here. So the place that exists is basically at the organization level. Go to settings, and there are a lot of bells and whistles to play with in the organization level. In there you will have the application security. Of course, you can bring in your own identity provider. It could be Asgardio, it could be Asia B2C, it could be Ping Identity, whatever, that will work too. But in this particular scenario, I'm just using the built-in identity provider. If I click on manage for that, you can see there's a username already. Let's use it to log into this particular TOI application. Copy the password, go here. Okay, demo, let's put the password in. Click on sign in. Yes. So given that I have data also, eventually this will load with some data. And this is how you deploy a front end and a back end. And yes. So let's create an account in Excel. Just let's use this particular front end so that I can send some API calls and basically to then I can actually show you how the monitoring, observability, that sort of things work. So let's create an account. One is going to be maybe put some random values. Click on create. Okay, so I created something. If I look at the history, I'm just using this. The reason being, I want to send some yeah, I think that should be enough. So now, up to now, what we did is basically create an application, take it to the production. Now the next thing is how you will monitor this particular application in production or whatever the environments that you deployed it in. So the way to do that would be go to observability and this menu. But before that, let's quickly observe what we have here in the architecture. Once you wire it up, this is how it looks like. Now you can see there's a new workload appeared in our architecture diagram. Live front end. You can see that this particular one talks to the backend. How does this happen? This happens because we created connections. When you create a connection, we know which workload works to which, and etc. And what this denotes is basically you have the traffic coming in. It goes to the live front end, and it will go and talk to the live backend, and the live backend goes and talk to the database. All these things happens because we know which workload talks to the which one, etc. Because it's governed, and we'll see the benefit of doing that in a next part of the demo in a live system that we run for WSO2. Before that, let's look at the observability. Click on matrices. At the project level, we didn't deploy this production, we deployed to development. So let's go there. Hope this is visible. Yeah. So when I go here, you will see request counts, error percentages, latencies, everything coming in. And towards this side, for the environment, development environment, last 24 hours, whatever the filtering that you will have the logs coming in also. So now to get to this level of details, traditionally you need to at least look at multiple systems, query multiple places, know a lot of tools and etc. But the beauty of this is this all integrated at this point. You can just traverse through and figure out what's going on at a very high level. And if you want to look at a particular workload, filter for logs or maybe observe. When you do that, you will see the let's look at last 30 minutes. You can see the request, basically the transaction rates, latencies, and memory usages, CPU usages. If you have a volume mounts and etc. for this particular workload, it will show you the disk reads, writes, everything. So it's all integrated. As well as if you want to look at the logs also, go to observability, go to runtime logs, filter for whatever the logs that you want to see. It could be the application logs, or it could be at the gateway level, somewhere here. And let's select all of it. Select the development environment, and what is the version that you are looking for, and etc. Let's look at the last 30 seconds, 30 minutes. eventually you will have the logs coming in here. In fact, you can actually search logs from a particular phrase as well, customer or something like that. Eventually this will come. So that's the observability part of it. And now nobody really wants to look at observability all day, every day. What you want to do is basically to receive alerts when something goes wrong. So the way to do that would be to go to alerts. And here you can configure different alert rules. Say you want to see, you want to get an alert if the latency goes down, or maybe traffic goes down or whatever. You can create these kind of alerts and receive emails and etc. Or either you can create things like logs. Say you have this catastrophic log entry that happens in the workload. If that goes down, everything goes down, etc. So you can have an alert for that as well. That kind of things can be possible. Or critical error happened or whatever. So for that you can create a log and you will receive alerts then in that way. That's the observability part of it. So now the next thing I want to show is to basically how we use Choreo at WSO2. So all our internal applications, starting from the performance reviews, the leave applications, expense management, everything runs on Choreo. So we have around 300 workloads running in the WSO2 for these things. It all runs in Choreo. If you come here, you can see there are around a little bit more than 300, and most of them are microservices. And there are a bunch of web applications too, and some other workloads. With Choreo, we can ship our workloads 26 times per week. That's more than 3 times a day, I think. And lead time for change is basically, if I commit a particular piece of code today, it takes around 22 days to ship that to the production on average, which is kind of okay, but then our frequency for deployments is really nice. So you can see the same thing for project-wise, and there are two things that I cannot actually show you, that is the mean time for recovery and the change failure rate. What these means is how many times I screw up in the production and how much time did it take for me to recover from that particular situation, etc. on average. So those things can be calculated as well. So this is basically real-time KPIs for your developer or DevOps velocity. Now, if I talk a little bit about the architecture of everything that we do with the internal applications, we closely do domain-driven design. So every domain in WSO2 for the internal applications are represented as a project. So, and these projects talk to each other. So you can see that the sales web talks to HRIS, sales goes and talk to HRIS, and etc. So if you look at one of these things, and let's take one thing at random, maybe sales web, you can see the architecture for that particular project. You can see the traffic coming in, these things are talking to each other, and there is a situation where these two workloads go and talk to a bunch of other things in another project, the HR project basically. All these things can be seen in real time. Now, suppose you have a couple of hundreds of workloads running in your enterprise or whatever the product that you are building. Knowing what goes where, how every workload communicates is a major challenge for any architect. Nobody knows this. It's not humanly possible to know everything. So in that scenarios, this particular diagram comes to your aid. When you are on Choreo, you know exactly what's going on. Not only at the design time, but at runtime too. So how do we verify that? So if I go to sales web again, if I go to the usage, no, sorry, observability matrices, let's look at the staging environment for the last maybe 30 days. Hope this is visible. Yes. So you can see how it works. So this particular workload received traffic from outside world, and there are a bunch of statistics available, request count, the error percentages and everything. But the beauty of all these things is, if you click on the diff, you will see the architectural drift. What this means is, all these dotted lines here represent a connection that you anticipated or configured in your project, but in the runtime, that particular traffic path is not having any traffic. Now, this is staging environment, therefore it could be that we are not testing it right now, that's why. But if this is production, and then you should be concerned. And there's another part to think about also. Suppose there are any red lines coming out of this, any of these workloads and going somewhere, that means this particular workload is talking to somewhere that you didn't really want to, or you don't know about. That's again a concern. This is how you verify whatever you drew in the design dashboard versus what's actually happening in runtime for the architecture side of things. We can figure out all these things because the higher level abstractions that we bring in with the internal developer platform, things like microservices, the connections, the databases, and etc. These are things that people are very familiar with, rather than worrying about the infrastructure as a code and etc. So that this is what we therefore begin to help people to write code faster and deploy these things even much faster than that. So anything else, Chintana, you want to add? Okay. Any questions from the audience? How much time do we have? Okay. So now the third part of the demo is basically to to show you how to use AI to we have Rania here, so Chief AI Officer for WSO2, and to basically interact with Choreo and get something done. So given the interest of time, I'm not going to use the same workloads that we used. I'm going to use a much more simpler something and deploy that to Choreo using AI. That's the whole idea here. So now what you saw here is what the UI we call the control plane generally. And there are two other ways to interact with Choreo. That is the IDE plugin that we ship with VS Code, Choreo. The other one is called Choreo command line tool. And this one particular tool can also act as a MCP server. Once it is configured, I could deploy something from here on itself. So let me quickly close this one. Let's start from the beginning. So I have a simple microservice, a toy app again, written using Python. Pretty simple stuff. You can see that it's just a sending bunch of hard-coded responses here. Let's see how we can deploy this. So once you configure everything, you have the Copilot coming in. What we can do is basically say login to Choreo and create a project. Maybe call it called live demo AI and deploy this API. Let's see what happens. So it wants to now log into the Choreo. Click on continue and it will show you some instructions. So it is basically listing out the organizations. Okay, where the login is. Okay, I need to log in here. It shows me a URL. Okay. So let's log into Choreo so that IDE can interact with Choreo. Okay, let's see. Okay, let's say do this again. So it will basically check what are the organizations that I have, and it will create the project now. This is the cover, basically the payload for that. I'm going to click on continue. Now the idea here is everything that will change my account will ask my confirmation. So, but you can have a switch, just go and do it kind of scenario as well. So let's see whether the project is created. If I go to my particular organization, let's go to Ramith. Yeah, live demo AI. The project is created already. So continue. So basically, let's see. It's going to create a service component. So let's see if the component is created. Yeah, custom API is there, and it had provided a nice description also for that. Let's see what the IDE is doing. So it basically got the deployments, but the deployments are not there because the build is not done. Now it's just going to build the workload. That's what's happening right now. Running git builds. So let's see. Let's verify that. If I go here, you should see a build happening. Trying to get the builds again. I think this is taking some time. Any questions at this point? So, okay, the build is done finally. Okay, the deployment is done. It will show you a summary of what it did, and it will show you the public URL for this particular workload as well. I could say something like generate the curl commands with test keys to access this URL. So basically it's aware that I have hard coded something here. So it basically says get the customer with ID 1. So expected response to be something like this again. Then goes for this second one because I have 2, and eventually it might say how to access a non-existing one as well. See, that's also here. So that's pretty much what we have to demo today. So maybe closing remarks and stuff. Okay, thank you.
Right, thank you very much.
Thank you, Pupudu, for that insightful session, and I hope every one of you is able to get an overview of the API management offerings.